All right, so we kind of discussed a little bit in 4.3 how to find the general characteristic of a graph, whether it's increasing or decreasing, and now we're going to get more into finding the shape of the graph. So, as we learned in 4.3, if f is increasing, then we know that f prime of x is going to be greater than 0, and vice versa. And f is decreasing when our first derivative is less than 0. Now, the interesting thing is that our second derivative gives us a little bit more information. So if f is concave up, if our second derivative is positive, and it's concave down if our second derivative is negative. So don't forget that concave up makes a smiley face, and concave down makes a grumpy face. Okay, so I made a little chart here that shows some of the possibilities. So let's say that we find our second derivative and it's negative, then we know it's going to be concave down, and we also know that, see, on this side of that dotted line, the slope is positive, so we know that our f prime is going to be positive. And when it's when it's concave down and decreasing on this side, then we know that f prime is going to be negative. Similarly here, when our second derivative is positive, then you can see on this side, we're kind of going to switch over. So our first derivative is negative, and our second derivative is going to be positive. That's a little bit easier to see if we look at this table. This table is awesome and crazy useful, so I don't know, put some hearts around it, maybe some stars, laminate it. So if we have our f prime value here, and we have our f double prime here, then we have 4 possible pairings, right? So we get a positive positive, positive negative, negative positive, or negative negative, and this would be the subsequent shape of our graph. Okay, similar to what we have here, we just put it in table form. So as you can see, when our first derivative is positive and our second derivative is negative, we're going to just get this little arc here. We're going to get this. All right, now we need to talk about points of inflection. So what is a point of inflection? Well, a point of inflection is when the graph changes from being concave up to concave down, or vice versa, when it changes from concave down to concave up. So it's when it changes concavity. So if we look at this picture here, we have a piece of a graph that's concave down, and we have a piece of a graph that's concave up. And if we put these two pieces together, we'll have a full graph, and at that point where it changes concavity, that's called the point of inflection. So how do we know when a point of inflection occurs? Well, we're going to be looking at the second derivative, and we're going to be looking at when that second derivative is 0, and that's going to be when our graph changes from concave up to concave down. So that's when it changes sign. So here, because this is concave down, we know that our f double prime of x is going to be less than 0, and here we know that our f double prime of x is going to be greater than 0. So this point of inflection here is when f double prime of x is exactly equal to 0. Now let's say for some reason we have a point where that's 0, but the sign doesn't change. Let's say that it was negative, and then it hit 0, and then it continued to be negative. That would not be a point of inflection. Alright, so let's do some examples. I love examples. You guys know that. You know I love examples. Alright, so let's find the critical values of this function here. So, unlike before, what we're going to do is that we're going to find the first derivative, and we're also going to find the second derivative. Alright, so the first derivative of this guy is going to be 15x to the 4th minus 20x to the 3rd. I'm just going to go ahead and factor this out a little bit. So that's going to be 5. I can pull out a 5. I can also pull out an x cubed. going to be 3x minus 4. And this equals 0 when x equals 4/3, and don't forget we have this x out here, so it'll also equal 0 when x equals 0. All right, let's go ahead and find the second derivative. So that 4 comes in front, making that 60x to the third minus 60x squared. So we can pull a 60x out of both of these. So that'll be x minus 1. And this one equals 0 when x equals 1. And again, don't forget about this x out here when x equals 0. Okay, now we're going to make a table similar to what we made before, only we're going to have a couple extra bits to it. All right, so we're going to have an interval. We're going to have a value. We're going to have the sign of our first derivative, and we're going to have the sign of our second derivative. Okay, and then we're going to have shape. All right, so let's pick an interval. So we're going to go from negative infinity to our smallest value, which is 0. We're going to go from 0 to our next smallest value, which is 1. Remember, 4/3 is greater than 1. Then we're going to go from 1 to 4/3, and from 4/3 to infinity. All right, so I need to pick a value between negative infinity and 0, so I'm going to pick -1. Between 0 and 1, I'm going to choose 0.5. Between 1 and 4/3, I'm going to pick 1/6. And between 4/3 and infinity, let's pick 2. Okay, now just like before, I'm going to plug these values in for my f prime of x and determine the sign. So I plug -1 in, I'm going to get a positive. So I'm going to have a negative here and a negative here, which will make a positive. I'm going to have a negative, and a positive. You can go ahead and enter these values in on your own, pause the video, and make sure that your values add up with mine. Same thing with f double prime. I'm going to plug in -1 to my f double prime. I'm going to get negative, negative, positive, positive. Now let's just take a moment. If I only wanted to know the concavity of my function, notice that I would have only had to do the critical values of x equals 1 and x equals 0. So that would actually cut this table in half, but I want to be more thorough to get the shape of the graph, so that's why I did both. On some of your homework problems, you're only going to be required to do one or the other, depending on how much information they're asking for. So if they're only asking for concavity, you only need to look at these videos, or not these videos, you need to look at all the videos, guys. Only need to look at these values for concavity. All right, so if you pull out the table that we just had, if I can find it, it's right here. So if I have that my first derivative is positive and my second derivative is negative, I'm going to have this shape. If I have negative and negative, then I'll have this shape. If I have a negative and then a positive, I'll have this shape. And if I have both positive, I will have this shape. All right, so let's see what that would look like in a graph. Okay, so we'll have, let's do 1, and we'll make this 4/3. Okay, and this is obviously 0. So if I'm going between negative infinity to 0, my graph is going to have this shape. Okay? So, this shape, and it's going to continue to negative infinity. All right, between 0 and 1, I will have this shape. So between 0 and 1, I'm going to have a shape that looks like this. Between 1 and 4, I will have this shape. And between 4 and infinity, I will have this shape. All right, wonderful. And notice that our sign of our f double prime changed between negative to positive when x equaled 1, right? So when we went from the interval from 0 to 1 to 1 to 4 over 3, we went from negative to positive. So this would be a point of inflection. All right, now you can confirm what your graph should look like on your graphing calculator. Now remember, this is just a rough sketch of a graph. It doesn't need to have the same x-intercepts or the same y-intercepts. It just needs to be a basic shape of the graph. All right, in the next section we'll be talking a little bit more about how to graph a function better.